Okay, this is going to be a review for exam 1. If you have not watched the recording for the formula sheet yet, do that first. You need to make sure you understand where all our formulas come from before you can be ready to do this review. Also, if you haven't printed this review out or somehow done it on your own yet, go through this whole review and do it on your own first. It's called Exam 1 Review. And then come back and watch this video and make sure you did it right. Okay, so what is a randomized controlled double-blind study? Randomized means chosen through some chance process. Controlled means investigators control who is in which group. So they control who is in the treatment group versus the placebo group. And then double-blind means investigators and subjects do not know who is in which group. This is called a randomized controlled double-blind study when all of these things happen, and that's our favorite kind of experiment. So if it's at all possible to set up the study this way, this is what you want to do. But remember, it's not always ethical to control who's taking a placebo and who's taking the real medicine, or it's not always ethical to tell people to smoke real cigarettes versus not smoke, stuff like that. So you can't always do this, but this is our favorite kind. If it's at all possible to do it, that's what you want to do. Okay, next question. The 2008 Women's Health Study followed a group of women who took either aspirin or a placebo without knowing which every other day for 10 years. So we've got aspirin or placebo. They don't know which they're taking. They're taking it for 10 years. The women who took aspirin had no difference in heart attack occurrence, but they were 17% less likely to have a stroke than the women who took the placebo. Give brief answers to the following questions about the study. Was the study controlled? How do you know? Yes. There is a treatment group. That's the people getting the aspirin. And a placebo group or a control group. And that's obviously the people not getting the aspirin, they're getting the placebo. Was the study blind? Well, it just said right here without knowing, so we're going to say yes. Subjects did not know which group they were in. Okay, was the study longitudinal or cross-sectional? So longitudinal means over a long period of time. Cross-sectional means the study was done at one time and they compared different groups to each other. So they compared a treatment group to a control group at that one time that it was studied. So this is a longitudinal, and we know that because they studied women for 10 years. Okay, a few years ago, a researcher looked at a large representative group of men. He found that on average, the older the men were, the less meat they consumed. True or false? And explain. The data shows that on average, men eat less meat as they get older. That is false. The reason that is false is because in order to compare men over time, you need to be comparing a man to himself. So you need to do a longitudinal study. So it's false. For this result, you would want to do a longitudinal study. You cannot compare men of different ages to each other. Without biasing the results. And the reason for that is because age is a confounding factor. It's very possible that the older generation lived through the Great Depression or through some hard time like that, where they did not have access to meat, or meat was very, very expensive. And so they just got used to eating less meat, and that's always been their diet. Versus now, meat is very readily available, and so it's not that hard to get a hold of it and consume more of it. Okay, number 4, just so you know the answers, 86 plus 56 over 2 is 70 something. 71. And it's equal to 10. I'm not going to take the time to do this problem because there won't be anything similar to this on the actual exam, so I don't want to waste your time. But if you happen to do it, it's good knowledge to have. So I put the answers there just so you can check it. Okay, according to USA Today, the age of getting knee replacements is distributed according to the following table. Sketch a histogram for the data. Okay, I'm going to make this into more of a table. Sorry for my not perfect lines here. This might hopefully look familiar to you from when we did chapter 3. Okay. What we're looking for here is the height for each of these, because I'm going to make a histogram and I need to know the bin height. So when I draw the histogram, I know what to label my vertical axis and how high to make each bin. 45 minus 18 is 27. So the height is equal to the percentage divided by the width, 0.1 repeating. So percent divided by width. And that's a formula on our formula sheet. The area is equal to the, the height is equal to the area divided by the width. Percentage and area are the same thing. Okay, 45 to 65 is 20. 25 divided by 20 is 1.25. 65 to 75 is 10. 43 divided by 10 is 4.3. 26 divided by 10, this is 10, and then 26 divided by 10 is 2.6. And 85 to 100 is 15. 3 divided by 15 is 0.2. So I'm going to make my histogram now. I'm my x-axis is going to have the bin. So I've got 18 to 45, and I'm going to try spacing this out correctly. So that has a width of 27. So then the next one, I'm going to have a width of 20. I'm going to make that slightly smaller than the previous width. 45 to 65, make half that width to get to 75, 85, 100. Okay, this is the age in years. Make sure you label your horizontal axis, and that horizontal axis is always what you're studying to come up with your results. So in this case, we're looking at how the age affects the number of knee replacements. Okay, the y-axis is going to be, so our vertical axis is going to be the percentage or percent per age. And that vertical axis always is a percent per the units. So we need all the way up to 4.3. So I'm just going to go up by 0.5 to 4.5. Maybe I'm not going to have room there. Well, I'm going to change my mind on that. And I'm not going to go by 0.5. I'm going to go by ones. 1, 2, 3, 4. That was very large. 5. Okay, first height, 18 to 45 is 0.1. I'm going to put above that what that height is. Next is 1.25. Okay, when I first did this problem, I used the percentage numbers, and that's wrong because this total area has to add up to 100%, and area is equal to the width times the height. So make sure you're using the heights here. 1.25. 4.3. Oh no, that was a little bit too big. 2.6. And 0.2. Okay, on the test, you're not going to have to create a full histogram, but you are going to have to fill in some blanks. So you won't necessarily need to know how to get this, but you will need to know how to take this information to get it here. We now answer some questions about this histogram. So, oops, I guess I can change pen colors, but I wanted to get rid of that circle. Okay, let's do green. So I'm going to answer these questions now. In which interval is the median age for these individuals? So median means there has to be 50% above. That is an ugly green, sorry. Above and 50% below. And that's 50% of the data. So we're looking where we can split this data so that the percentage is 50% above and 50% below. Notice this is 28. This is 29. So to get to the 50, to get the other 21% and 22% to get to 50%, we're going to be somewhere in the middle here, which means this is our interval that holds the median, 65 to 75. Now, let me change that color because that's hideous. Okay. About what percentage of individuals were 70 or older when they had the surgery? Okay, we're going to use our histogram. We're looking 70 or older. So we're looking that section, and that section. we're looking for the area that I just shaded. Before we got into our normal curves using shade norm, to find area, we did a formula from our formula sheet. Area equals width times height. Well, we know to get from 70 to 75, the width is 5, and the height on that bin is 4.3, plus this width, 75 to 85, is 10 with a height of 2.6. 85 to 100 is 15 with a height of 0.2. So if I type that into my calculator, it's 50.5. So half of the subjects in our study got a knee replacement after they were 70 years old. Make sure you don't have a number bigger than 100% here. It is a percent, so it needs to be somewhere between 0 and 100. Okay, indicate approximately the average and the median on the histogram. So I'm not going to do it for this specific histogram. I'm going to make it a bit more obvious for a histogram on where they would be. Actually, let's do this. So I'm going to make a histogram that's skewed way to the right. The average gets pulled to the direction of the tail. And that's from the median. So the median needs to split it 50%, 50%. So if I look at the area, where would I have 50% of the area shaded? And I'm going to guess, see, I'm going to say it's probably about here-ish. That's just a guess, but I'm going to call that the median. Okay, I just want to undo that 5. So this is the median. And then the average gets pulled towards the tail. So if there is no tail, the average is where the median is at. That would be for a symmetric. The average and median are both in the middle. But if there is a tail, the average is going to get pulled the direction of the tail. So this is skewed right. So our average is going to be pulled this direction. So our average would be something like that. This is something you need to know. More the average is pulled towards the tail is what you need to know. So make sure you've got that part memorized or make a note to yourself so you can find out when you're taking the test. Okay, next page. Adult American women's heights have a distribution that is approximately normal, meaning we're allowed to do just our normal stuff with it, with an average of 63.5 inches and an SD of 2.5. So average 63.5, SD of 2.5. What is the percentage of women between 61 and 68.5 inches? When I read a problem like this where it says percentage and I'm not dealing with a histogram anymore, I'm just given an average and an SD, I know I'm going to be doing shade norm. And there's 3 steps for shade norm. We covered those 3 steps in the formula sheet, but let me remind you. Step 1 is draw the normal curve. Step 2 is to find Z, and Z equals the entry minus the average over the SD. Step 3 is to plug it into shade norm. Okay, so we're going to use those steps. We know that we're looking between 2 specific amounts. So I'm going to draw my normal curve, and I'm looking between 61, well, the average is 63.5, 61's below the average is in the middle, and 68.5, okay, that's quite a bit above 63.5, so I'm going to put it here. So I'm looking for this area. Step 2 is to find the z-score. And z equals our entry minus our average. Well, we have 2 different entries. So we're going to have to do it for both 61 and 68.5. So entry minus the average over the SD, that is -1. Entry minus average over the SD, that is 2. So then step 3 is shade norm. We're looking from -1 to 2. So remember, on shade norm, you do the lower bound. So this was our lower bound, upper bound. And then always 0 and 1 and hit equals. Okay, I'm on my iPad. I downloaded the the Graphing Calculator X and then bought their updated or cooler version of it. So I'm going to show you how to do this on my graphing calculator. It's pretty similar to the TI-84. It's not identical, but it is basically identical. Just a couple of the steps are weird. So I've cleared out previous drawings. So I'm ready to just go second vars, shade norm. And then it tells me right at the top, right at the top as I start typing what I need to type in. -1 is my lower bound, 2 is the upper bound, 0, 1. And then if I want to choose a color, the colors are 1 through 15. I don't know what color is what, so I'll just choose one. Let's do color 6. Hit enter. It just says done. It doesn't show me the graph. So I have to go into the graph and it shows me that graph. And if you hit trace, yeah, this stuff that's at the top there is for a different one. So let me hit trace and just click in it, and it shows that area right there at the top. I guess I chose the color orange, so it's showing it in orange. So the area, it says 81.859461%, so I'm going to say it's approximately 81.9%. Okay, what percentage of women is taller than 67 inches? So you're going to do the same thing on this one. Draw. The average is 63.5, so I'm going to put 67 somewhere above that, shade that area in. Step 2 is z equals 67 minus what we were given over 2.5. Let me check that out. 67 minus 63.5 divided by 2.5, not 25, 2.5 is 1.4. So we're looking for the area above 1.4, meaning our lower bound is going to be 1.4. The upper bound is always 10. Remember, if you're not given a lower or upper bound, use a big standard deviation, which means -10 or 10. -10 if it's on the left side, 10 if it's on the right side. And then 0, 1. And we type that in, so 1.4, 10, 0, 1. Let me... Oh, close is right here. Okay, so I'm going to clear out the previous drawing and do it again. Vars, nope. Second vars, shade norm, and it was 1.4 to 10, always 0, 1. Most of you have just the normal window where you can type in lower bound, upper bound, and so on. And then, oops, I'm going to do color 3 this time. We'll see what it is. Hit enter. I'm going to my graph, and it shows it right there. And I want to know, so I'm going to hit trace. I want to know the area inside this. Maybe. trace. There we go. 0.0807. So it's about 8.1%. .1% of women are taller than 67 inches. Okay, then we've got this question. What percentile would she be in if she's 59 inches? We're going to do slightly backwards of this. I'm going to say a woman is at the 15th percentile. What height is she? Okay, since this is backwards from how we normally ask the question, I'm giving you the percentage, percentile, basically the same thing. This just means 15%. Everything below some amount is 15%. We have to do inverse norm. So we're going to go inverse norm, and then the numbers you type in there, it will ask you for the area, that's 0.15, and then it's going to ask you for mu, or the average, it's a fancy M. The average, we were given clear up here, the average was 63.5, and then it will ask you for the standard deviation, 2.5. So this one's nice because you can just use the actual average and standard deviation. You don't use 0 and 1. So we're going to type that into our calculator. This is a 0.15. Let me fix that on here so it's really clear. Because it was the 15th percentile, that means 15%, so 0.15. So we're going to go to our graphing calculator, clear out previous work, just so it's not messing anything up. And then this time we go second vars, but instead of arrowing over to draw, we stay in distribute, or distribution is what it stands for, and choose option 3. And we'll see if this works. I'm not sure if it will work on this. 0.15. I don't know what V stands for there. Oh, I think I chose the wrong thing. That's why. Second vars, option 3. Yep, I did. There we go. So 0.15, and then it was 63.5 and 2.5. Hit enter, and our answer is right there. The woman would be 60.9 inches tall or 61 inches tall. So I'm going to say about 61 inches tall. Remember, if you see a given percentile and it asks you for the number associated with it, it means do inverse norm. Okay, that was all the questions on that one. How many pages do we have left? Cool. Okay, for a Stat 1040 class with 380 students, the first midterm average was 78 and an SD of 10. So we have an average of 78, SD of 10. Second midterm, average of 70, SD also equal to 10. Correlation coefficient is 0.8. This is the 5-number summary. And if you see a 5-number summary, that means you are dealing with linear regression or a scatter plot. Okay, if 10 points actually, I don't think we need this question. Definitely don't need that question. Don't need this question. Those students who scored one average above or one SD above average on the first midterm averaged less than one SD on the second midterm. This data supports the professor's claim that students tend to lose interest during the latter part. Okay, what this goes back to is the regression fallacy. I started writing false instead of fallacy there. Oh, I guess I had spelled it right so far though. Okay, this was a true or false question, so that's what I'm answering here. So this is false. Regression fallacy. And what that says, if people score really high to begin with, they're going to score not quite as high the second time around, because if you're already at the top, there's not much more room for improvement. You tend to do not as well the second time around. The main thing you needed to get from this is if you see this 5-number summary, you know you're dealing with a scatter plot. I don't think actually I know the regression fallacy is not on the exam. Number 8 is dealing with the regression fallacy, so let's not take the time to go over it. Number 9, a large group of students took 2 successive IQ tests. Correlation between the two is 0.8. Both tests have an average of 100 and an SD of 15. If someone scores 75 on the first test, which is most likely? 75 on the second test, less than 75 on the second test, or somewhat more than 75 on the second test. Okay, it was an average of 100, so this person who scores 75 is lower than the average, so they're in the bottom group, which means they're probably going to go up. And again, that's the regression fallacy. It's good to review it. I see it on the final sometimes, but it is not on exam 1. So don't worry too much about that one. Okay, this one has a 5-number summary here. The question is, what does R measure? That is how closely the data is related. So, how well can we use this data to predict other data? What would the scatter plot look like? Remember, a scatter plot of 0.6 is going to be a little bit more than the average football shape, so it's going to be a little bit fatter. So it looks something like that. Correlation is computed in the calculator. Now there's a big long process, but for us it's calculated in the calculator, and you can look at the calculator instruction sheet to see how to do that. You will have one problem where you need to calculate. Actually, nope, you won't have any problems where you need to calculate R. So just know that it can be done in the calculator. You don't ever have to do it on the exam. You'll always be given the information. Okay, so those 2 pages, they were kind of a waste of time. Hopefully you looked through them at least though, just because it's good to review that material, but you won't be tested on it. Okay, this information is where we're going to start actually working with the 5-number summary and where you need to make sure you know what's going on. So I'm going to transfer this 5-number summary over 75, 15, 80, 17.6. I already lost it. 75, 15, 80, 17.6. Okay, so this is average, SD, average for Y, SD for Y. Find the slope of the SD line. I'm not going to make you do that on the test, so let's not take the time to. If you did it, it's just the SD of Y over the SD of X. Let's just do it. 17 over 15. That's it. The slope for the regression line, this is the one we care about. To get that slope, it's the same as C, except it's 0.6 times that. Because the formula found on our formula sheet is R times SD of Y over SD of X. And make sure you're using Y over X. So I can calculate that. 0.6 times 17 divided by 15, 0.68. Don't worry about E. Find the equation of the regression line for predicting end of year score from beginning of year score. So that's still end of year is Y, beginning of year is X, because you're predicting Y. If you're asked to predict something, it's always Y. So the formula is Y equals mx plus b. We already know the slope. What we don't know is the intercept. And if you don't know what that formula means, look back at the formula sheet and make sure you've watched that recording. I go over it through the formula sheet recording. To get the intercept, there's this formula on that formula sheet of using the average of the x times the slope minus the average of the y. And I'm just going to double check that real quick and make sure I've got that memorized because I don't have the formula sheet right in front of me. Okay, formula sheet. Oh, my computer's being very slow to load up. It'll get there though. Average of y. Okay, so I wrote this backwards. Let's try that again. That's why I checked. Intercept equals average of y minus slope times average of x. The average of y is 80 minus slope times average of x. So that's 29. So our formula is 29. Okay, you've now seen me calculate that regression line equation 2 times in the formula sheet recording and in this. On exam 1, you will be given this formula, but it's beneficial to know where it comes from. But what you really need to do is know how to use this formula. So G says use the regression method to estimate end of year score. We're going to change that and say use whatever method you want. So when it says regression method, it's meaning doing the 4-step process, which is kind of a waste of our time. So we're just going to say estimate the end of year score. And to do that, we know on the initial test they scored 75. So we're going to plug that 75 in for X. Do 0.68 times 65 plus 29. And that will give us what we would predict somebody to get on that end of year test. Okay, 73.2. So what that means is if somebody initially gets a 65 on the initial test, we expect them to get a 73.2 score on the final test. Then it says find the RMS error. The way this is going to be phrased is how much do we expect the prediction to be off by? And that answers this question. What does the RMS error measure? So I said this on the formula sheet. I'm saying this again. If you see that question, how much do you expect this prediction to be off by? It's meaning do the RMS error formula, which is a formula on our formula sheet. It is RMS error equals the square root of 1 minus r squared times the SD of y. And we have that information up above. We know r is 0.6, SD of y is 17. So I'm going to type that into the calculator. Square root of 1 minus 0.6 squared times 17. Okay, I'm arrowing out when I type times 17 so that I can make sure it's not under the square root. And it looks like I messed that up thoroughly and used a negative instead of a plus. Let me try that again. Okay, 13.6. That's much better than 103. So we expect it to be off by 13.6 points. Okay, for those students who score 65 on the beginning of the year test, what percentage scored 75? Let's not answer that question. Let's do a different question instead. Let's say somebody initially scored 65 on initial test. Would you be surprised if they got a 95 on the end of year test? Okay, would you be surprised? That means, is it more than 3 standard or RMS errors away? Is score more than 3 RMS errors away from expected? I'm out of room here. Okay, let me squeeze this in somewhere. So we expected 73.32. Or sorry, just 73.2. If we go 3 standard deviations above that, let's check if 95 is in that range. So 73.2 plus 3 times 13.6 is 114. So that means nope. We are not surprised. Okay, don't worry about this. I think I got rid of it when I uploaded it, so you probably don't even have that. Okay, there's your review for this. I will be doing 2 different practice tests as well, so you can watch those videos. Also, make sure you jump in on our office hours that I'll be holding before we take this exam, so you can ask me questions there, or ask me questions on the discussion page, and I can answer them there as well. Please just let me know what questions you have. I'm just sitting at home waiting for you guys to ask me questions because I can't leave the house just like you guys can't leave the house. So, well, I guess we can, but we shouldn't. You know what I mean. Okay, ask me questions. Good luck studying.